हेलो स्टूडेंट। आज का हमारा टॉपिक है एक्सपेरिमेंटल मेथड्स ऑफ एक्सरे डायफ्रैक्शन। एक्सरे डायफ्रैक्शन हम तीन मेथड से कर सकते हैं। एक है लाue मेथड, दूसरा है रोटेटिंग क्रिस्टल मेथड और तीसरा है डिबाइसेचुलर मेथड या पाउडर मेथड। सबसे पहले हम देखते हैं लाue मेथड। In this method, a single crystal is held stationary and a beam of white X-ray radiation of continuous wavelength 0.2 angstrom to 2 angstrom is inclined on it at a fixed glancing angle theta. The crystal selects and diffracts the discrete values of wavelength lambda, satisfying the Bragg's condition, which is यानी कि इसमें एक सिंगल क्रिस्टल को ना स्टेशनरी रखा जाता है और एक बीम वाइट एक्सरे बीम रेडिएशन को जिनकी वेवलेंथ होती है हमारे पास 0.2 एंगस्ट्रम से 2 एंगस्ट्रम को उस पे इंसिडेंट करवाया जाता है जो कि एंगल थीटा बनाता है। एंगल थीटा जो होता है हमारे पास वो फिक्स्ड होता है। हमारे पास इसकी इक्वेशन होगी 2d sin थीटा इज इक्वल टू n लैम्डा। Liu in his very first experiment used wide radiation of all possible wavelengths and allowed this radiation to fall on a stationary crystal. The crystal diffracted the X-ray beam and produced a very beautiful pattern of spores, which confirmed exactly with the internal symmetry of the crystal. Let us analyze the experiment with the aid of Bragg's equation. The crystal was fixed in position relative to the X-ray beam. Thus not only was the value for d fixed but the value of theta was also fixed. मीन्स दैट कि इसमें हमारे पास ना सिर्फ d फिक्स होता है बल्कि हमारे पास जो थीटा है वो भी फिक्स होता है। The only possible variables therefore are the integers n and wavelength lambda। जो हमारे पास possible values हैं जो चेंज हो रही हैं वो सिर्फ हमारे पास integer n है और wavelength lambda है। With the result that in the Liu photograph each observed reflection correspond to the first order of reflection of a certain wavelength, the second order of half the wavelength and a third order of a third of the wavelength and so on. The Liu photograph, which is obtained from a single crystal, is simply a stereographic projection of the planes of the crystal. Second है हमारे पास rotating crystal method. In this method, a monochromatic beam of X-rays is incident on a single crystal rotating about a fixed axis. The variation in the angle theta brings different atomic planes into the position for reflection, satisfying Bragg's condition 2d sin theta is equal to n lambda. Each producing spot on the film. The position on the film when developed indicates orientation of the crystal at which spot is formed. The data obtained from these spots reveals information about structure of ordinary and complex molecules. In the rotating method, a single crystal is rotated about a fixed axis in a beam of monoenergetic X-rays. Due to rotation, there is variation in the angle theta. The variation in the angle theta brings different atomic planes into position for reflection. यानी इसमें जो एंगल थीटा है उसमें वेरिएशन होती है, वो चेंज होता रहता है क्योंकि वो जो जिस पर हम क्रिस्टल पर हम जब इंसिडेंट करवाते हैं रेडिएशन तो वो मूवमेंट कर रहा होता है। A modified rotating crystal method is used for structure determination when a single crystal specimen is available. A simple rotating crystal X-ray camera, the film is mounted in a cylindrical holder concentric with a rotating spindle on which the single crystal specimen is mounted. The dimensions of the crystal usually need not be greater than 1 millimeter. The incident X-ray beam is made nearly monochromatic by a filter or by a reflection from an earlier crystal. The beam is diffracted from a given crystal planes whenever in the course of rotation the value of theta satisfies the Bragg's equation. Beams from all planes parallel to the vertical rotation axis will lie in the horizontal plane. Planes with other orientations will reflect in layers above and below the horizontal plane. The intensity distribution of the radiation from a 30 electron volt X-ray tube with a molybdenum target. नेक्स्ट हम पढ़ेंगे अपनी नेक्स्ट वीडियो में इंशाल्लाह।